All right. Scholars, we now have to make sure we have our calculators. And it's actually a little bit easier if you have a TI-84. A TI-34s do the same thing, but one thing you have to make sure is when you have this on, it has to be in the right mode. And we need it to be in degree mode. So you go down and you highlight it by hitting arrow over, hit enter, and it's highlighted. To get out of that screen, you go second quick. Okay? But now we have to be able to set these up. Now the cool thing is, for every 37-degree angle, I know its sine, cosine, and tangent ratio. And those are all programmed into the calculator for us. We don't have to do the work. But we have to make sure we know how to set it up. So here's how you do this. After you make sure your degree, make sure calculator, we'll put this down, in degree mode. All right. Now we sit there and all you have to do is hit sine. So you have your sine key. And then you should have it, if it doesn't automatically show up, you should put this here, parenthesis. You plug in your angle, which is in 37 degrees, put a close, okay, you punch that in, do a close parenthesis, okay, hit enter. And let's go to the 4 places after. So let's go 0.6018. Now make sure you know how to do that on your calculator so you get that decimal. That decimal is just the decimal representation of its ratio. Do the same thing for the other ones. You'd have to go cosine, go 43, parenthesis, hit enter, should be 0.7314. Tangent, same process for tangent. We go tangent of 24. We should get 0.4452. So calculators are going to be key for doing these, and you're going to see me be very specific. Now, I'm going to give you the 3 types of equations that we mainly have to set up when we're looking for the side. It is not hard, but you will be graded on these 3 steps. Did everyone hear me on this? You will be graded on these 3 steps. I will see all 3 steps, okay? So on the first one, how do I decide which ratio I'm going to use? Well, first of all, why don't we write over here so we can have a reference. My sine is opposite over hypotenuse, cosine adjacent over hypotenuse, ca, and tangent is opposite over adjacent. So it lets me know how to set up my equations. I also have it on the board in my room, so that will help you, but you're going to have these memorized before you take your quiz on Friday. If you're taking the quiz on Friday, some of you will have different dates. Anyway, you have to know the angle you're working with, and if they give you more than one, choose the angle you want and just claim that process. So I'm looking at this angle right here. Well, if that's the angle I'm working with, x is my opposite leg, and 15 is my hypotenuse. So which one of my ratios has the opposite leg and the hypotenuse? Sine. So this is how you set it up. The sine of 28 degrees equals opposite over hypotenuse. Now you have your equation set up. Now this is just like what we did on the front page. Now how do I get x by itself? I multiply both sides by 15. And you can show that work if you want, or you'll learn that it always will work that way on this case. So I get the 15 times the sine of 28 degrees equals x. Now it's you punching it in. This is to the nearest tenth. So I go here, 15 sine. Notice I just put the 15 in. I plug in the sine, parenthesis shows up, go 28 parenthesis. I get to the nearest tenth, 7.0. I look at the 100 spots, it's under 5, so we leave it. But in order to show that you're approximating this, you do need to include the 0. So that would be approximately 7.0. I use approximate symbols. You may use equal signs. Just know we're not getting an exact answer because we're not including all the decimals. So we have to make sure we have that. But you will be graded on the actual equation, what you're going to put in your calculator, and your final answer. That's the 3 steps you're going to be graded on, what you see there in blue. Now looking at the next one, here's my angle. What sides am I talking about? Well, that's my opposite leg. This one is your hypotenuse. Well, what uses, once again, opposite and hypotenuse? Sine. So your cool thing is, if you notice, I'm just plugging in either the angle or the legs. There's always 2 out of 3 pieces of information I'm putting in. So here I get the sine of 65 degrees is opposite over hypotenuse. That's 10 over x. Now, on the board, I showed you the long way of doing this, but I also gave you a shortcut. I'm using the fact of properties of proportions. When I have properties of proportions, I can switch the extremes. They can trade spots. So for my second step, I need to show what I'm going to put in the calculator, and it's going to be that way. But that only works if I'm looking for the denominator of that ratio, okay? I can flip-flop those. Notice that didn't happen over here. These are the two scenarios. So now you just have to punch it into your calculator again. I'll just go 10 divided by sine, close your parenthesis, 65. And so that should be 11.0 because I'm going again to the nearest tenth. All right? So, oops, let me show you how it looked on the calculator. All right, good. Now let's do the same thing for the next one. Now this is my angle I'm using. Well, is that opposite or adjacent leg? Adjacent. This is your hypotenuse. Now which one of your ratios, if I go back up here, has adjacent leg and hypotenuse? Cosine. So I go the cosine of 32 degrees equals adjacent over hypotenuse. X over 13. X over 13. All right, so when I do that, I just go solve for x, multiply 13 to both sides, and now you just punch it into your calculator. Let me show you one more time how to do that. You just go 13 cosine 32, close it off, and I want to go to the nearest tenth again. Oh look, it's below, the 100 spot is below 5, so we just go approximately 11.0. Okay? And let's look at the next one. When we have this one, again, for this angle, that's your adjacent, this is your hypotenuse, okay? So I'm still going to use cosine, because cosine's when I have adjacent leg and hypotenuse. So I get the cosine of 40 degrees equals adjacent over hypotenuse. Oh look, here I have the denominator is the one that's missing. Do switch your extremes. So I get x, like put it over 1 and then switch them, equals 6 over the cosine of 40 degrees. Go ahead, make sure you have this 6 divided by cosine, we get 7.8. Alright, are you guys with me so far? Here's the diagram, what you punched into your calculator. Alright, let's look at the next ones. I'm looking for, again, this angle's information. So I sit there and mark, what do I know? I know the adjacent leg, and I'm looking for the opposite leg. Oh wait, when do I have opposite leg and adjacent leg? I go up here and go, oh, opposite and adjacent is tangent. So I go tangent of 55 degrees equals opposite over adjacent. Oh look, I'm going to get x by itself, so I multiply both sides by 5. Okay, then go ahead and punch it into your calculator. So I'm going to put it in here. I'm just going to go 5 tangent 55, close it, and you get 7.1. So x is approximately 7.1. Not too bad. Now let's look at f. Again, here's my angle. This is my adjacent leg. This is the opposite. We're going to use which one again? Tangent. So I go the tangent of 62 is opposite leg over adjacent leg. Oh look, we have the denominator again, that I have the variable of x. Swoom. Flip-flop it. Switch your extremes. Remember that's over 1. I can switch my extremes and it's still true. So I get x equals 12 divided by the tangent of 62 degrees. So what do we get here? 12, oops, make sure divided by tangent of 62. Close. Okay? I get 6.4. All right, those should be very easy to set up. But you have to notice I marked what I knew here, and marking up your diagrams will be very helpful. All right.